All right, great. So we have the Q&A section now. We have 14 questions that our attendants have submitted. The first one, we have this one's for Dominic. What is the difference between a baghouse and a cartridge collector for cement applications?
So as we explained earlier in the webinar, they're both excellent dust control devices. The Baghouse is more rugged and generally better suited for most cement applications because cement applications tend to have a heavy dust load, meaning that for the amount of air that goes into the Baghouse, a lot of dust is going with it. Cartridge collectors work very well in many applications, but when there's a lot of dust loading, it's not always the best. If you're going to use a cartridge collector in cement, it almost needs to be the vertical style where the cartridges hang vertically like bags. If you use the horizontal style, a lot of times the problem is that the dust builds up on the top of the filter and it can't be pulsed off. And then you have like a big mountain on each top of each of the cartridges, and you effectively block off 40% of the cartridge. So if you're going to use a cartridge, it needs to be a vertical one. But generally speaking, for most cement things, you're going to want to stay with a baghouse because no matter how much dust you throw at it, as long as it's sized correctly, it's going to work very well.
All right, thanks. I have another one for you, Dominic. In a cement plant, does an ESP achieve higher collection efficiency than a baghouse?
So ESP meaning electric static precipitator. Generally speaking, no. ESPs are really only used on really large applications. So we're talking at a cement plant, it'd be like at an actual cement kiln where you have the massive cement kiln, maybe 500,000, a million, 2 million CFM. That's where you would see the larger ESPs. In the past, they were a viable alternative to baghouses when you considered the overall costs and over the life of it and things like that. Basically, they're giant energized plates, and when the air comes in, you ionize the air, and then the particles in the air get attracted to the plates. So it works very well to remove dust without having to use any filters. Over time, though, they haven't quite kept up with the super strict emission standards that apply in some cases now at larger facilities for major sources. So a lot of ESPs over the years have been converted over to baghouses because baghouses still are the best and most efficient when it comes to the absolute collection efficiency. Some smaller applications use wet ESPs where they use water inside of it. Those are comparable to baghouses in a lot of cases. But they don't really, just for a lot of other reasons, they don't usually end up in cement, water and cement dust, obviously not mixing very well. But normal ESPs versus baghouses are almost always more efficient and are required basically according to the most current regulations.
Great, awesome. Okay, so we have another one for Matt. What is a process baghouse dust collector and a nuisance baghouse dust collection system?
Yeah, so a process dust collector, a process baghouse usually means that it's part of the process. So rather than just collecting dust that you want out of the building, out of the, out of the way, it's collecting something that's going to be either recirculated back into your process or used in your process. So for example, we recently looked at a copper plant where the material that's being collected by the dust collector is valuable, process output. It's being processed through the dust collector and recaptured. And it might be collected in bags or might be conveyed back into a silo or something like that. But it's not just nuisance dust that you just want to get rid of. Oftentimes we'll see, it might be a silo bin vent or something like that, where you're not trying to just get rid of the dust, you're putting it back into the system. Sometimes you might see a process where there's an actual chemical process that's being done inside of the baghouse, and the what's discharged out of the baghouse is part of the product and process. Whereas if you're just talking about dust that's coming off of your conveyor belts, your elevators and so forth that you want out of the facility, with your pickup points, moving it out to a baghouse to be disposed of, that would be more of a nuisance baghouse versus process baghouse.
Great. Awesome. All right. So now question 4. What affects the price of a baghouse filter, Dominic?
So we always say there's like the list of things when we're considering what filters to use. What's the temperature is the first one, followed by what kind of dust you're collecting, followed by what kind of chemicals are taking place in the process, and the last one is the price. So we divide everything first into temperature. So is the process about 260 Fahrenheit or less? If it is, we're almost always going to use polyester filters because they are most durable, they're the cheapest, and the most easily acquired. If it's more than that temperature, we're going to probably use aramid filters. And the aramid filters are the same thing, but for a higher temperature up to about 400, 425, depending on the exact aramid you use. Things get more expensive with temperature, and then they get more expensive with chemicals and that require treatments and things like that. So if you need acid-resistant treatment, oleophobic treatment, and then later when you need PTFE membrane added to your bags to improve the collection efficiency, improve the dust release, all those things make the bag more expensive. And then one last thing that makes it a little bit more expensive is when we add certain features to the construction of the bag to make it more durable. So the most common ones are adding wear strips, tough cuffs, double disc bottoms, things like that. They're usually on the bottoms of the bags, and they usually are put there with extra material we use and sew on the bottoms, and it gives it extra resistance to abrasion. So those usually add a few extra dollars if you decide to put those on. A very good investment if you have problems with abrasion. Highly recommended. But yeah, those are the things that make the bags more expensive.
Nice.
And also, if you need them, rush, obviously, because very few bags are made and kept in stock. So if we get a request for something like emergency rush service, obviously there's a premium to bump people out of the way of the production queue. So if you want something rush, most bags are about 3 to 5 weeks lead time. So if you want like 1 to 3 weeks lead time, 1 to 2 is usually about maybe a 20% premium. And then in certain cases, we can do, within a week if there's an emergency. And then that depends greatly on the load and things like that. But that could very easily be 50% or 75% extra to rush them out like that.
That makes sense. Okay, good. Number 5, Matt. How often do cement dust collection filters need to be replaced?
Yeah, we get that question a lot. And the answer is it depends, right? So how often you change your bags really depends on how hard the bags are being worked, how heavily loaded they are, how difficult your process is. So it really comes down to monitoring the differential pressure across the filters. So in a situation where you're heavily loading the bags, it's a 24/7 operation, and those things are being worked continuously, you might have to change them every few months. Whereas in a more lightly loaded scenario, one shift operation, intermittent use and so forth, they might, last for years. But the way that we know when the bags need to be changed is because the DP gauge will tell you when they're blinded. So over time, you'll see brand new set of bags, the differential pressure gauge on your baghouse will be very low. It'll start out, at 1 inch, and it'll sort of creep up over time as the bags are cleaned. It goes up and down, but then over time you get up into 5 and 6 inch, range, and the pulse cleaning system can no longer adequately clean the bag, so they're hanging up there in the 5 and 6 inch range on your Magnehila gauge. That's a sign that the bags are nearing their end of life, and they're going to need to be changed, as soon as possible. So what we recommend is people track the differential pressure. You should be checking it daily, weekly at least, so you have sort of advanced notice. If you're monitoring your process, you should have plenty of advanced notice and be able to predict when those filters are going to reach their end of life. Occasionally, you'll have issues also where the bags will simply fail early, and that could be due to a baghouse design issue or some kind of a process issue, temperature spike, which is less predictable. But if you're managing your process, you should be able to, make a graph of the DP over time and see, when you get up into that 3.5, 4.5 range, that, at a certain period of time in the future, your bags are going to be blinded and need to be changed.
Good.
I would just add too, you can affect this by the way you operate your baghouse as well and how you maintain it. So a big thing that impacts how long the filters last is if you over clean the filters. So we talked earlier about the importance of doing the baghouses on clean on demand setting, where they only pulse the filters when the differential pressure reaches a certain level, and then turning off once it's cleaned it down. If you just have it in timer mode, you're increasing exponentially the wear that goes on the filters, because most of the wear that causes the filters to reach the end of their life is from pulsing the filters. It's not from the dust hitting them. Also, if you over clean the filters, you have less dust cake on the filters that protects the bags during their operation. So if you blow all that off, because you're always pulsing the bags get beat up and have nothing to protect them. So that shortens their life a lot. And then also, if you have the baghouse that's either not maintained well or it's too small, that affects how long they last. And then lastly, if you have the wrong kind of filters, so if you just have the cheapo plain ones in there and you have some kinds of chemicals or things like that, upgrading to have certain treatments can extend the life. Or like we were talking about, adding things like wear cuffs and reinforced bottoms, things like that, can extend the life out. So there are some things you can do to extend it a little bit, if you make those decisions about maintenance and investing in the right kind of filters.
Great. Thank you. That was a good comment, good addition. Number 6 is for you, Dominic. Can a cement dust collection system be integrated directly into a grout mixing plant?
I think I would need a little more information on exactly what's meant by that question. Maybe the person that that asked that can follow up with us later by email and we can talk about that a little more detailed. But I think maybe what they're referring to is, can we integrate dust collection systems directly into like the process machinery? So yes, in some cases you can. Things like blasting machines and stuff like that a lot of times have the dust collector, like the wheelabrator machines, stuff like that. They have the dust collector part built right into the same cabinet, so to speak. In general, in cement and mining and things like that, in the past, I think we mentioned this earlier, there used to be where we would sometimes build in like a modified dust collector into the conveyor belt or the conveyor system. And like we would shorten the filters and put them this way, all this stuff. We don't really go that approach anymore in most cases because those systems don't work very well when they're hacked up and put together like that. It's usually better to have the kind where we have a central system that pulls through ductwork from those kinds of spots. So we have a central. It's also more efficient to have one bigger collector than lots of little ones, in most cases. So yeah, whether to integrate something into the process equipment or to have a separate standalone dust collector, it depends on the circumstance, but yes, in certain cases, it can be done.
Great. Awesome. So I think we have another one, number 7. What regulations govern cement dust emissions on U.S. construction sites? Maybe Matt, would you like to answer that?
Yeah, I'll take a shot at this one. So there's a few things that could apply to your facility. So to start, if you're a manufacturing, mining, or processing facility, the OSHA standard duty clause will apply to you, which basically is very non-specific, but it says you have a duty to protect your employees from an unsafe working environment. And so, following that, depending on your facility type, you most likely will have specific OSHA or MSHA standards, which would apply. And that includes like permissible exposure limits for respirable silica. Depending on the other materials and processes of your site, there might be other standards that would apply. NIOSH, makes recommendations for exposure limits. I think, if you're working with silica dust, you should refer to your MSHA respirable crystalline silica standard. And I know that in the last couple of years, those standards have gotten more stringent. So a lot of facilities that were operating, with looser standards have been forced to adopt new measures to pull dust out of their facility to meet the new standards. And, I won't comment on the specific limits because those tend to change over time, but it's the, required for the facility to be aware of those standards and make sure that they're compliant. So I would refer back to the OSHA standards for your specific facility. If you're a mining facility, the MSHA standards.
Nice. Great. Awesome. The next question, maybe Dominic can give it a shot. How to prevent moisture incursions into our dust collection systems?
So moisture in your baghouse is like the ultimate enemy. So you want to keep it out at all costs. If you have to live with it, then you need to do a couple of things to make sure it doesn't mess up your life. So the first thing is if you have a process where there's some kind of moisture, steam, things like that, you have to design the pickup of the dust collector pickup very carefully. So for example, we have a customer where they're mixing hazardous waste with different kinds of clays and things like that to stabilize the material before they dispose of it in a landfill. And they had a lot of problems because they have a misting system to help control the dust because it's in a big room. But the misting head was right next to the pickup hood for the dust collector. So basically all the mist was just getting sucked right into the dust collector. So seems like an obvious problem, right? But that kind of thing is what we have to design around, make sure we're not unnecessarily sucking up moisture where we don't need to. If you do have moisture that gets sucked up, say, we have a lot of like gypsum and things like that. You have a lot of like kettles and batch cooking and things like that where you have moisture that comes out, you get steam. You can handle steam and moisture in your dust collection system, but everything must stay warm. You cannot have any condensation. And then it's not so much the moisture, it's avoiding condensation. If you have that, it's actually your friend to keep everything very hot. Most of the time we want to keep the temperature lower, but when you have moisture, you want to keep everything warm. So from the ductwork all the way through to the baghouse and even the exhaust in the baghouse, you might want to insulate. And then many times we even have to add extra heaters like heat tracing or even natural gas heaters sometimes, but that's much rarer. Usually it's heating pads, heat tracing, things like that. And we might even modify the process a little bit so that we run at a higher temperature. Sometimes we adjust how far the hood is away from like a furnace or something like that so that it sucks in less ambient air so that the gas that is going through is hotter. And then the startup and the shutdown procedures become very important for dust collectors. Basic idea, heat the baghouse and ductwork up first and then let the process gas go through. And then when you shut down, you have to purge everything with clean air. So run it with clean air running through it for a few minutes to get all the wet, moist gas out. And then you can turn the system down because then the temperature will go down. And that keeps you from having wet gas in the baghouse and passing through the dew point. So then you don't get condensation. And that's really what the problem is. It's not so much the moisture, it's condensation.
Right. But and
Can I piggyback on that? Sorry, Andy.
No.
Just for more general, ambient temperature applications where you just, as a general rule, you don't want moisture getting in your baghouse. Basic maintenance becomes important so that you don't want, if you have a baghouse that's outside, you don't want moisture getting sucked in the access doors and things like that. So basic maintenance is important. Checking your door seal should be a part of your quarterly, if not monthly, preventive maintenance procedures so that you have airtight, enclosure in the baghouse. Doing the same thing for your ductwork, because over time, if you have abrasive dust at a cement plant, you may wear holes in the duct elbows and things like that. And eventually you might find out that you're pulling in ambient cold or moist air, outside of your process into the baghouse. So those are pretty common scenarios where we'll see moisture in the baghouse. Basic stuff like door seals and holes in the ductwork or, flanges that aren't properly sealed, things like that.
Absolutely. Great addition.
Yeah. Thank you for adding those comments, Matt. Excellent. And related to that, maybe you already mentioned on this, Dominic, a little bit, but question number 9, from your experience, what do plants and OEMs struggle with the most in these type of systems? Is it typically airflow distribution, abrasion, and wear, leakage, structural fabrication tolerances, difficult retrofit conditions, maintenance accessibility, or something else. There's so many options.
Um, oh, that's a good one. So in talking about these industries, cement, mining, um, there's a lot of common problems. Some are big, some are small, some are maintenance related, some are design and capital expenditure kind of related. I guess I could maybe mention a few from each category. Maybe Matt, you can get some other ones, but I would say a big problem on a small scale is not having accurate and reliable differential pressure readings. And related to that is the clean on demand versus timer setting. A lot of times that's a result of not having reliable readings. The differential pressure readings are super important because they're the only way to know what's happening in the baghouse. So any discussion about maintenance, optimization, any of that stuff, even emissions as well, what's going out the exhaust stack, for pollution control. All of that, the first question is, what is the differential pressure? And then the second one is, what is the differential pressure when we do this? So if you don't have reliable readings that you can trust, it's always a suspect. So you never actually know what's happening. It makes diagnosing problems very difficult. A lot of times it's because we don't spend enough time cleaning out the lines and making sure the gauges don't get fouled. And also having the right kinds of gauges that are, rugged, and just maintaining them. So changing them when they get fouled. They get fouled very easily. In fact, we often recommend these little auto blowout devices that we install on a lot of our systems that keep the lines clean automatically, because then you always know what the reading is. The other thing is the reading is on a gauge up 300 ladders, 1,000 feet in the air. Nobody's going to go read that. So it does nothing, even if it is working. For an extra $100 on the cost of the gauge, you can have it send the signal down to the control room and record it on the computer. So why would we not do that? It makes perfect sense to upgrade to a slightly nicer gauge that sends the readings one place. And then the person that used to go and take those readings now can do inspections and preventative maintenance and all this other stuff. So that's a big one. I would say with regard to design and things like that, the number one thing is always the baghouse is undersized, because in the quest to get the lowest possible price, there's always going to be some vendor among the 3 or 5 that you get quotes from who will always tell you that their system can do more with less, and that's why it's cheaper. Or sometimes it does happen too. The plants know enough about the system, so they specify they want something that's smaller, more aggressively sized to save costs. For all the different reasons, people might want to have something be lower cost. Once it's in, it's not that it works or doesn't work, it's that it works poorly, works acceptably. Whereas if you sized it the right way, it would work really well. So a really well-designed baghouse, even in cement and mining, is one that you close the door after putting the filters in, you clamp it down, and you don't open it again until 1-2 years later when you change the filters. And that's the only time you open it, because it has no problems otherwise. When it's too small, you're in there all the time. You're getting holes in the filters every month or two. You're getting like 80% of the suction you need, right, at the pickup point. So it's getting most of the dust, but there's still dust on the floor. It's still dusty in the plant. And that's what a lot of sources. So I'd say that's probably the biggest big picture thing is systems are too small, undersized for the application, or they were the wrong type of model, like someone bought a cartridge collector and they should have had a baghouse, those kinds of things.
Yeah, I'll add to that because we've been in so many facilities and all of these things happen. There's all of these symptoms are present, but the thing that seems like most facilities nowadays have trouble with is just the fundamental maintenance, because you have to train your maintenance and your operations staff on all the fundamental baghouse inspection maintenance procedures, right? And so when you have a lot of churn, it's hard to keep people, you lose that every few quarters, when you have a new batch of maintenance staff. And so those new people may not know the fundamental, what to look for. Like Dominic said, the DP gauge, nobody knows to look at it. So it just goes, it goes and gets worse and worse, and then all of a sudden there's issues in the facility and people are wondering why. So I'll use this opportunity to kind of plug our services. We do a lot of on-site inspection maintenance services. I would recommend you do that once in a while, if not on a quarterly basis, just to make sure that those things are being addressed. And then over time, these type of facilities have a way of changing over time. Processes get moved around, pickup points get added, often for good reason, right? Because, you have a new machine over here, you need to reroute this ductwork over there. And we'll go in these facilities where the dust collection system may have been perfectly designed to start with, but things have changed. Ducts have been added, pickup points have been added or moved or closed off. And then you have balancing issues in the ductwork. You've added pickup points and sort of watered down the airflow at each of the pickup points where you need it. And people are then kind of left scratching their head as to why, it's so dusty in the facility. So the other recommendation I would make is if you're planning to change to your facility, if you're going to add a machine or remove a machine or make any kind of change to the ductwork, the layout, and so forth, you should look at the dust collection system, have someone who's familiar with the system look at it very closely to make sure that you're going to have enough filter square footage, enough fan capacity, and that the ductwork system is designed properly so that you don't have issues as a result of that. So those are just two common things we see. All of the issues that Ian mentioned, Andy, airflow, distribution, abrasion, all that stuff plays into it. But if you can make sure your maintenance staff is trained to kind of recognize the symptoms, or you get, an outside expert like us in there every once in a while to take a look at things, you can address them before they become systemic, chronic issues in your facility.
Nice.
I would just add, it's always the small things, it's the basics.
Mhm.
People always think we're going to come and find some like crazy complicated thing that requires a team of engineers to solve and millions of dollars. The vast majority of what we find when we do inspections, and that's in our reports, it's lots of these little things that we mentioned that can be resolved with better training or just attention and resources dedicated to it from maintenance operations team.
Yeah, most of the reports are like basic stuff. Door seals, pulse valves, fix the leaks here, things like
Change
that.
the filters.
Yep.
Mhm. That's true. Thanks, guys. Thanks for that answer. Okay. Question 10. We have 5 more. How do I deal with corrosion inside the baghouse? Dominic, would you like to?
Most corrosion is from condensation, from moisture coming out. So all the things we mentioned before, making sure you have no condensation anywhere in the system. What Matt said is very true, though. The vast majority of corrosion in any baghouse, if you go up, it's always around the door, around the airlock, and around the flanges of the ductwork. And that's because those are the places the gaskets get worn out and air leaks in. So you have cold, wet, humid air outside leaking into the hot air. So you have condensation, or vice versa. When it's winter, you have cold air that goes into hot gas, and that's where you get the condensation. So making sure the door gaskets and all that are in good condition, there's no holes. And just one other detail that gets overlooked a lot of times when we go to open the baghouses and the bolts are just finger tight. So they have the good gaskets, but they don't appreciate that they have to really clamp the door down. And that's where the leakage is because they're not clamping it down.
Yeah, just to add to that too, you mentioned already, making sure your temperature is high enough so you don't get, condensation. And then I'll add one other thing. We recently have partnered with a company called Eon Coat that makes a ceramic coating that you can apply to steel structures like the interiors of baghouses. And it's a extremely high temp and extremely corrosion resistant coating. So we've had a recent, application that had a lot of hydrofluoric acid along with high temperatures, very challenging, super aggressive corrosion on the baghouses. But this coating you apply basically, and it lasts for years if it's done properly and maintained, and it resists corrosion. So in a super challenging application where you just cannot manage the temperature, or you have some aggressive acids or chemicals in there that are going to attack your structure, something like that could be an option as well.
Nice, Matt. Excellent. So I have another one for you, Matt. What is respirable crystalline silica, and what is the acceptable occupational exposure for RCS, or respirable crystalline silica?
Yeah, respirable crystalline silica is basically silica dust, but it's so fine that it can be breathed in, or it's respirable, and it's of a certain size. The standard is so small that you typically cannot see it as airborne dust, but you can breathe it in, and it can cause all kinds of problems. Like, there's lung conditions that are specifically attributable to respirable silica dust. And so the reason it's regulated is because it's dangerous. You can give yourself lung cancer due to repeated exposure or chronic exposure, or even, single instances of like high dose exposure. So I won't comment on the specific limits again, because they tend to change, but you need to check if you have silica dust at your facility. You're almost certainly, regulated by the OSHA and MSHA exposure limits for respirable silica. So you got to check the regulations and make sure you're compliant. If you're not sure, you need to go do some testing with the sniffer and make sure you know what's going on in your facility, and design a dust collection system so you can get that out of the facility.
Nice. Okay. Dominic, how do I prevent ductwork clogging and hopper breaching in my cement plant? What would you say?
So for the duct work, the name of the game there is making sure the air moves fast enough that nothing falls out. So the air needs to move at or above a certain speed we call the minimum conveying velocity, to keep the dust particles entrained or floating in the air as it moves through the ductwork. If it goes any slower than that, the dust will start to settle and fall out, and then it'll start to build up and you get plugging. But before you get it plugged or clogged like that, the problem has existed, and that's why it's been building up. So related to what Matt said earlier, many are surprised to find out that the ductwork is actually the thing that requires the vast majority of the engineering time. Not the baghouse, not the fans, it's the ductwork. It's the thing that most people have backwards. They usually think the ductwork is like the dumb part of the system. But getting it the right size is important, because we're artificially making it small, so to speak, so that the air moves really fast inside. That's why for the volume of air we move, the ductwork is relatively small compared to like HVAC ductwork, which moves a fraction of the amount of air, but is the same size or larger than our big industrial ducts, right? So making sure all the parts of the ductwork system are sized correctly. You can't simply connect another hose or another line on. You can't simply close one off here and put another one on, because everywhere two ducts come together, the duct needs to get bigger, and like a tree trunk, and then the next branch comes on and it needs to get bigger. And if you change any of those things around, you will have buildup that basically starts happening. Or you can have the opposite, which is where the air goes too fast and you have a lot of wear and things like that. In the hoppers, bridging is a big problem with a lot of materials. That comes down to the kind of dust that you have. So some things are stickier, tend to agglomerate more than others. But a main thing with thinking about the dust collector part of it, big thing is not storing dust in the hopper ever. So as soon as dust is blown off the filters, pulsing, whatever dust falls in the hopper should hold that dust basically until the next pulse, and then that's it. So you pulse one row of bags, whatever falls down, the airlock or screw, whatever you have on the bottom, should remove all of that dust, and the hopper should be completely empty before the next bags are pulsed. So basically the hopper never stores dust. A lot of the bridging and all that stuff happens because we have an idea that the hopper, because of the name, which is a very bad name for it, is supposed to hold material. It's not. Absolutely essential. As soon as dust is blown off, you remove it out of the hopper. That goes for at the end of the day. We start up, it needs to be empty. And that's all the more important when you have materials that have the potential to bridge like that and stick together.
Can I add one thing to that? Talking about the ductwork, since we're talking, cement applications, one thing that's pretty common in crushing, part of the process in particular, you'll see a lot of cement plants have this grasshopper leg style ductwork. And that's pretty common. And the idea there is to basically ensure that the heavier stuff that gets pulled off your conveyor hood falls back into the process while the lighter dust goes up into your ductwork. So you want to make sure that the ductwork itself is sized properly to keep the lighter stuff flowing. But you'll see those grasshopper legs, which are designed so that when your system shuts down or for whatever reason, you don't have dust settling. And when the system turns off, usually you're collecting all the fines through the ductwork. The heavy stuff kind of falls back into the process. There are some challenges, some issues with that style of design, so it needs to be done carefully in specific applications, but it's very common in cement plants and heavy kind of crushing applications and things like that. And then another good practice is just to have clean out doors and access panels in your ductwork so that as part of your quarterly inspection process, you can go look in your ductwork and see if you're getting dust settling, vacuum it out if you need to, and just make sure you're keeping tabs on it before it becomes a big issue.
Nice. All right. Okay. And since I have you there, Matt, the question 13, how to monitor air quality in a cement plant? What would you say to that?
So there's a few different things that could mean. So just as a general, what's the air quality inside my facility? There's air quality monitors that you can use and sniffers, and there's various different devices. Some of them you can carry them around with you. You can connect them to your phone or clip them on. They're basically just air quality monitoring, real-time measuring device that will tell you the exposure and the air quality and how much dust is in the air and so forth. So just to get a baseline of what's in your facility, you can start with that. There's all kinds of sensor options. We have Dust IQ, which is kind of an IoT connected sensor system or operating system. So you can add air quality sensors wherever you want in your facility. If you want them to, have a dashboard showing it in real time, what's the air quality, how much dust is in the air at any given moment, we can do that, and we highly recommend it. There's also, quality sensors and particulate sensors that you can put in your ductwork on your fan exhaust, so you can see if you're getting dust bypassing the filters, prior to having a visible emissions issue or you have to shut down. You can put sensors in particulate sensors and broken bag detectors in your exhaust duct to give you a warning if you're starting to see, air quality issues on the clean side of the baghouse.
Great. Awesome. And the last question, Dominic, here says, how to control fugitive dust emission in our cement plant? They said that they are already using baghouses, ESPs, and dust suppression methods, but the problem still persists. What would you say?
I would say you need to have someone like us come out and review your plant, see what the problem is. But I think the general idea is probably something that a lot of people maybe experience at their plants. So they feel like they've got everything. Why is it still such a mess? Or the other way, it could be a lot of people kind of just are resigned to the fact, oh, I work in this industry, it must be dirty all the time. We have one of our customers, mining minerals, things like that. For many years, the plant culture, the company culture was that this is a very dirty job and you go home completely dirty every day. And then after some new ownership came in, doing the same thing at their plants, they were spotless. And it's been taking many, many years to change the culture to the idea that, no, you can have the same process and do it and the plant be relatively clean, right? So a lot of times, if you have all the equipment and the plant is still very dirty, a lot of times it's like we said, these smaller things. It's the ductwork that has been modified a million times over the years. And now everybody just assumes that's as good as baghouses work. They suck up most of the dust, but the area around that machine is always going to have dust all over the place. But that is not a adequately functioning baghouse. That's like a chugging along baghouse that's just barely alive, right? When it's designed correctly, maintained correctly, and operated correctly, dust collection systems will get 99.99999% of all the dust that's generated from something. So there's no reason you have a Raymond mill, there's no reason you have kettles, if you have belt conveyors, crushers. None of those machines are incapable of being clean around them if you have the dust collection designed right. So it might be redoing the ductwork, might be that too many things have been added onto it, so you got to remove things and make sure the full power of the system is going to the pickups as it's intended. Or it's just maintaining it again. Sometimes we go and they don't change the filters, or they change them every 10 years, and they think that's normal because they don't have the DP gauge telling them it's 10 or 12 inches. They see a broken gauge with water in it, and it says 1 inch, and they go, oh, well, our air permit says less than 5, so we must be good. And then, you put a new gauge on and you see it's actually like 10, 12, so there's no suction basically through the system, right? So it could be a lot of different things. But this is where when we come into our inspections and then our training, a lot of times plants are able to finally figure out the problems. It's not because we're so much smarter than everybody and all this. And it's not that the plants are so negligent or anything like that. It's just you need somebody sometimes to come and point out things in a very specific way and then lay out a roadmap that you can follow. You just don't have the bandwidth to be making cement, to be working in mining, doing all the things you're supposed to do, and then somehow also be experts in dust collection. So having us come, find all the little problems, lay it out, and give you a pathway to fixing them all. Many times that's all it takes. And then what you have is fine. You don't need to buy new equipment. You just need to use what you have adequately and maybe show a little bit more care to it, and then it'll work just fine.
Great. Thank you, guys. Thank you. Great questions and excellent answers. Thank you so much.